Hello to all my lovely Math 1 students. So you've learned a little bit about Pythagoras. Let's take a look at his famous Pythagorean theorem. So first of all, Pythagorean theorem is always applied to a right triangle. And we have some new names for parts of the right triangle. The hypotenuse is always the longest side of a right triangle. Let's take a look at these three triangles. Which is the hypotenuse of each? Well, if you look, it should seem fairly obvious that this side is the hypotenuse. If it's not obvious, you can see that the hypotenuse is always opposite the right angle. So go into the green triangle here. The hypotenuse is opposite that right angle. Excuse my terrible writing. Yellow triangle, where's the hypotenuse? Well, this looks like the longest side, and to confirm it, and you don't need to draw that arrow in, I'm just doing it just to make it really clear, the hypotenuse of each is now labelled. So what do we call the other sides of a triangle? Well, it's maybe a funny name, but they're just called the legs. So the other sides are just called legs. We don't really differentiate between these. They're just the legs. It's the hypotenuse that we're most drawn to when we take a look at the lengths of sides of a right triangle. Okay, the Pythagorean theorem. You've played around with a couple of activities and probably seen this, but the most simplest way to state the Pythagorean theorem is a squared plus b squared equals c squared, where c is always the hypotenuse. And A and B, it doesn't matter which way around you label them. So this is the Pythagorean theorem. I'm also going to show that this can only be applied to a right triangle. First example, we're going to find the missing side of this. So first check, is this a right triangle? And it certainly is. Therefore, we can apply the Pythagorean theorem to this. Which of these is the hypotenuse? Well, I'm going to just check that my hypotenuse is here. So I'm going to call it C. You can call it hypotenuse too. Sometimes it's also called X. And A and B can be either of these. The first thing that I'm going to do is state the Pythagorean theorem. A squared plus B squared is equal to C squared. It does not matter which way around A and B are labelled, but I'm going to write down 6 squared plus 8 squared is equal to, and I don't know this yet, it's equal to C squared. 6 squared, 36. 8 squared, 64. C squared, don't know yet. 36 plus 64. So 100 is equal to C squared. I'm going to take the square root of each side. And that leaves me with an answer of 10 is equal to C, or C is equal to 10. So that's quite a lovely number. Sometimes it's not going to be a nice whole number. This is actually what we call a Pythagorean triple. It's a special triangle where each side is a whole number. 6, 8, 10 is a Pythagorean triple. So it won't always be a whole number like that. So if you want to pause now and just take a look at that example, make a note if it's helpful. This is just a straightforward example of how to find a missing side. Let's take a look at another one. Okay, so we have another triangle. My first question would be, is it a right triangle? And it is indeed. So we can apply the Pythagorean theorem to it. A squared plus b squared is equal to c squared. Where's the hypotenuse? Well, the hypotenuse we actually know. So that's going to be C. I can call these A or B. Sorry, not B. Sorry, that's G. I don't need to call it anything else because it's G. And let's take a look. If we can apply this, we then have 5 squared, which is A, 5 squared plus G squared is equal to 10 squared. So in this is a different example. I know what C is, but I can still apply it to the Pythagorean theorem. Subtracting 5 squared from each side, we end up with G squared is equal to 100 subtract 25. G squared is actually equal to 75, and we can take the square root of each side to get G is equal to the square root of 75. It is acceptable to leave this as an answer, but if you had to approximate it or work it on a calculator, you could as well. Knowing what we know that would have to be between 8 and 9. G is somewhere between 8 and 9 because 8 squared is 64, 9 squared is 81. So it's somewhere between the two. So if you need to rewatch this video, please do so. But that's the Pythagorean theorem.